Let's now solve this exercise again with the same story: force, magnetic field, and current. Now this combination of a current that is passing through a magnetic field and then feels a force. Okay, so what is the problem? Here we have a wire. Okay, so this whole rectangle here is a wire. You can read the problem, but I'll be describing to you what it is. Okay, you can stop, read the problem, and then listen to what I'm saying. So we have here this wire carrying current. No? So you have this current going down here to the right in this part and then up here. No? So it goes down to the right and then up. Okay. In addition to that, there is a magnetic field. So these blue dots here are indicating the magnetic field. You remember that this dot means out of the page, so that means this magnetic field all around is pointing towards our eyes. No, it's coming out of the page. But it's a funny thing, it's a bit unphysical. No, we have the magnetic field only at this piece of the wire. So only this piece of the wire feels the magnetic field. Okay, before we go into checking more about that, let's see. Only the part of the wire that is within the region of the magnetic field will feel a force. So let's just as an exercise think about what is going to be the direction of the force for this piece here. Okay, so what we have in this piece here, let me make my drawing here. So this part here is the part that we're discussing now. Okay, so we have the current going down, we have the magnetic field coming out, right? The magnetic field coming out, and we want to find out what is the direction of the force here. What do we have to do? Well, our fingers, they have to be pointing, the four fingers, they have to be pointing down. So something like this. Our four fingers. The palm, I'm going to denote my palm like this round thing. Okay, so the palm has to be coming out of the page, which means the thumb of my hand is pointing to the left. Okay, so the direction of the force here is to the left. So play with your own hand and you will find this result. Okay, let's see now what is happening at the bottom here. At the bottom here we have the current going to the right. We have magnetic field everywhere towards us. So to find the direction of the force in this part, what we have to do, point our four fingers to the right, the palm coming out, and so the thumb is pointing down, right? The palm is the thumb is pointing down, so that means we have a force here pointing down. And we can go on and do the same exercise to the right side of this wire, and you will find that there is a force here to the right. Okay, this particular problem that we are studying is only interested in what is happening in this region here. Okay, and you see that they even put the arrow of the force at this point. And they say that this rectangle, this wire, is attached to a scale, to a balance. And this scale is able to detect, measure this force. And they tell us, if you go on reading the problem, you see that the value of this force, the magnitude of this force, this F here pointing down, the value of this force is that number 3.48 10 to minus 2 Newton. Okay? All right. What else do we know? Well, this current is uniform, is the same all over, this steady current, and the value of this current is 0.245 amps. Okay. The question now is, what is the magnitude? We already know the direction. Now, what is the magnitude of this magnetic field? Now, we know the direction. The direction is in the drawing, out of the page. And we want to know the magnitude. How are we going to do that? Well, let's go back to that equation, the equation that we just talked about, this one, right? So if I write this equation here, we have the force is equal to the current, the length of the current that is within the magnetic field, and sine of the angle between the current and the magnetic field. This is what we need. Okay, let's go back to our problem. In our problem, what do we have? We have the value of the force, right? So 3.48 10 to minus 2. We have the value of the current, 0.245. Now comes the question, do we have the length? Well, this is the length. We are studying the force on this piece of the wire. So this is the length. And if you look at the drawing, we know this length. Now it's 10 centimeters, so 0.1 meters. So let's put it there, 0.1 meters. B is what we don't know, is our unknown, so I'm marking it here. And then the question now is the angle. What is the angle between the magnetic field and the current? Well, look, the magnetic field is coming out of the page. The current is going to the right, so they are perfectly perpendicular. And so the angle between them is 90 degrees, and the sine of 90 degrees is just 1, so we don't need to do anything else. So this is the equation that we have to solve. And if you solve, you will find that the magnitude of this magnetic field is 1.42 Tesla. And that's the end of this part.